Okay, I want to throw a little bit at you about residuals, kind of building off our previous example. We're looking at a model. We've generated a model. Here's our model, and we're using it to predict grades given the hour study. So for example, as we saw in the last video, if we study for 8 hours, then what we expect for a grade is a 91. Our predicted value of a grade is 91.6. Okay, so what we can do then is go to any particular data point. I'm going to pull up our data points. Let's go to this first data point. This person studied 8 hours and got a 98. Consider the point 8, 98. Study for 8 hours, got a 98. The predicted value is 91.6. So the residual is just the difference. 98 minus 91.6, which is 6.4, I think. You could check the subtraction on your own. Let's consider a different point here. Now this, maybe look for another 8. Here's another 8. Or we get a bunch of 8s. Here's one down here. Look at this one. This person studied for 8 hours but got an 84. Right? Consider 8 hours and an 84. So the residual for that data point is 84 minus 91.6. That's going to be 85, 86, 87, 89, 7.6. Negative 7.6, I think. Maybe I subtracted wrong. And it's captured on video. How embarrassing. In any case, what we can do for every single data point has a residual. If we want our model to be any good, we want those, obviously residuals aren't really a great thing. We want our model to be predicting an actual value. We want our residuals to be small. That would mean the model was doing a good job. So any decent model that is a line of best fit is going to cut through this data in the best way possible to minimize the residuals. We want to minimize. That is to say, the line that we asked our calculator for, we've already done this. We want to minimize residuals. And so when we look at this thing, which you have, if you can't see that too well, pull out your own copy of it. When we get our line of best fit, we're finding the line that has minimized the residuals. We actually square them so that they're positive, so we can minimize the square of the residuals. And how we do that gets into a lot of detail. So when we ask our calculator to do the linear regression, it has, for you, laboriously gone in and found this line right here, which is the same as this line right here. It's a linear equation. Here's the equation form, graph form. It's found that line to minimize the residuals. And where we'll head into next, into the gory details, which we started in class and didn't end at a very good place, is how do we minimize residuals? That is, what's our calculator doing? What's under the hood of linear regression? By hood, I'm referring to like the hood of a car, the engine going inside. What's under the hood? That's not a Bill Belichick reference or under that. Anything so interesting as that. What's under the hood? What's going on with linear regression? Stay tuned.